Long, long ago, there was this gas. It was called miasma. And everybody believed that when people died, that the cause was miasma. And not until research was done and funded, it occurred to people that it may be something else. There were little particles, not microplastics, but pathogens, bacteria, viruses, through air, through water, that caused these large epidemics. Cholera, Spanish flu, and what I hope is today that we find that the research is needed to find out whether microplastics can be a concern, a major concern for public health. I must admit, last week I was at the World Health Organization in Geneva, where that blasted report came from, with this very complicated message. And there we discussed how to use water safely in irrigation. And we probably need to understand that worldwide, wastewater is largely untreated. 20% of all our wastewater is actually treated, which means you can do the math. We're not very good at percentages, but you can do the math. How much is left that goes into our environment untreated? 80%. A 10 for math. So what are we worried about? We are worried about very small particles, indeed microplastics, but maybe nanoplastics in our environments that are put there by us every day, the whole day, all the time, and have been done for centuries, as we heard this morning. What we're worried about is those plastics themselves. What we're worried about is everything that's in it, the toxic substances that we just heard. And me, or should I say I am worried about what's on the microplastics, because actually what we've learned is that on the microplastics, microbial populations may grow. There may be bacteria, there will be bacteria in the environment, that can actually use these microplastics as a service, and a very good service at that, to grow on. This is what we would like to find out. So are these biofilms or microplastic particles actually a cause of any human health concern? Well, I have to admit, they probably do. Why? In our rivers, also in our Dutch rivers, but as we've seen pictures, mostly also in other countries, we have widespread pollution. And this widespread pollution comes from our wastewater. That's what we just learned. But it also means that it carries our waste. So whenever you go to the toilet, remember me. All these pathogens that we carry, whether we're sick or not, will be flushed down the toilet into our rivers. So in these rivers, plastics or no plastics, we'll have pathogenic bacteria, viruses, and parasites. And they will be moving. They'll be flowing with the river flow into the sea, which if it goes far enough, is not really a problem. But however, what about these pathogens on the microplastics? They may behave differently. So that's our hypothesis for our research. Should we be worried because these pathogens, although they're in the river, they can also be on these plastics. And on these plastics, their mobility may be increased. I forgot my slides. I got into the story. So are we worried about pathogens? And I haven't really explained this, but there may also be virulence and resistance genes. And as we all know, antimicrobial resistance, alongside climate change, is one of our major worries. What if these resistance genes travel further along the route on these microplastics than they would normally do when they attach to other particles and maybe go into the sediments of our rivers? Well then, so this we really want to find out. We know that besides exposure to water, exposure to air is also a grave public health concern. Actually, in the Netherlands, we now have wastewater treatment plants that emit Legionella bacteria in aerosols, and they may reach people that live not even that close to these wastewater treatment plants. Is this a problem? Well, we are actually on it, so research is being done, but how do these microplastics play a role in this? We know there's all these different transmission routes for infectious diseases. Now we want to find out the microplastics. So what are we doing? We're sampling the River Rhine in this case, just a few samples. It's a pilot project, but near the border with Germany to see what comes in, and also near sites where we have recreational water activities, intake of drinking water treatment plants. And so we were wondering, can we isolate DNA and then look into whether we can find these virulence genes? Can we find antibiotic resistance genes? Well, I must admit, I'm a bit worried, but yesterday, yes, we did find resistance genes on the plastics. Nothing unusual, we find them in the rivers, they'll be on the plastics, but do they travel further or differently than they did before? So we work together with KWR. They do our microplastics analysis. They perform the sampling. So I'm very grateful to work together with Patrick Bauerlein, who's been very active over the summer, and with Rosemarijn van der Plaats, who is a real expert in next-generation sequencing. And they found, actually, some results. They found the resistance genes, and we did find that in the larger microplastic particles, actually, they sort of seem to be differently in their profile as compared to smaller particles, as compared to the surface water itself, the river water. So that's what we need to find out. I have some things that I don't want to leave unsaid. So one of them is actually that we're not completely sure whether this different mobility is actually a problem, so we need to find out. The other thing was also already mentioned, does exposure to pathogens and genes on plastics, does that lead actually to different or additional health impact? I'm not sure. We need to find out. But we need to collaborate, and so that we'll do. We're going to find out if these genes and these bacteria, these pathogens on these plastics, if they have a different result on the immune system, if combined with microplastics, together with researchers that are actually also in our National Institute of Public Health and the Environment and at Utrecht University, where I'm a professor. And lastly, I should also mention this. What about global impact? As I mentioned at the start, we are worried about all this waste and all this wastewater goes into the environment and all the plastics and pathogens that go with it. So shouldn't we also be worried what happens in other countries? Well, we do. So we work together with the World Health Organization. I'm actually the director of one of the WHO collaborating centers. And what we do is we look into risk assessment of pathogens in food and water, and we'll try and find solutions also for people that do not have wastewater treatment, that do not have a good public health infrastructure. And being a woman, I almost become flooded with tears because we really have to do something. Thank you.